Today we'll be making a DLL injector. Let's go ahead and start up a C++ project. Make it the console application. Keep it simple. Alright, let's begin. The main idea of a DLL injector is you open up the target's address space and you write in the path to the DLL, and you force the call to load library on that string that you've written into the process, which will force the application to load the DLL. This is just a bit of boilerplate code. I'm used to kernel development, so it might look weird. Okay, let's start off with the function to actually inject the DLL, and then we'll add all the other shit into it to actually find the process by name, etc. Function is going to accept two arguments: the process ID of the target, which is basically just a number that identifies the process, and the DLL name, which will be the full path to the DLL. The first thing, you're going to want to make sure these arguments are valid. The process ID can't be 0 because that's the process ID for the system process, which acts as the kernel. So you're actually not allowed to open that process. Okay. Set up our variables. We're going to need a handle to the process. We're also going to need a variable just to store our memory allocations. We're going to need the size of the DLL's path. I think that's about it. Yeah. Okay, so first things first, we're going to want to open up the process. Using open process, pretty straightforward. We're going to ask for all access. There we go. It's simpler. You really don't need to, but it's just simpler than specifying all the flags. Making sure that the process handle is valid. And after that, we can move on to actually allocating the memory inside the process. So we're going to use virtual alloc EX, and we just specify the process handle. The starting address, we really don't need that. We just want it to be inside the process somewhere. And this is where the length comes into play. We want to add one to the length because for C strings, at the end of each string is the null terminator. It's basically just 0, and that tells it that the string is done, but when you get the length of the string, it cuts that off. So we're going to want to add some more for the memory allocation. making sure that the alloc is successful. And once we've done that, it would probably be a good idea here to initialize this variable as well. Yeah, that's fine. Next, we're going to write the DLL name into the process in the memory we just allocated. Write process memory actually returns a boolean that tells it whether or not it succeeded. So we're just going to check that. The last argument is optional, but it tells you how many bytes were written in. A byte is just a character. And to make sure it's false. If we were going to exit. Two things I forgot actually. We were going to need to get the address of load library A, which is just the ASCII version of load library. It's in kernel 32, so we're going to need to get that address as well. And we can do that here. Kernel 32 should be, by default, mapped into every process. So we just need to use get module handle A. Again, error checking. It's a good habit. And to get the load library address, we use get proc address on the kernel 32 base, and we just tell it the name of the function we need. In this case, load library A. Next, we've already written the DLL path into the process's memory, so we should just be able to use create remote thread ex, just create remote thread, my bad, which will force the creation of a thread inside of the target process, and we will set it to execute at the load library address with the parameter set to the string we injected. Pretty straightforward. Yeah. This is all there is to it. There are more complicated forms of DLL injection if you want to get around, I don't know, some anti-cheat or something, but I've yet to find one that can successfully block against just manually mapping it in. It's really complicated. It involves relocating the entire DLL and injecting it and setting up everything yourself. And it's really quite uncommon, so I'm not going to be the one that spreads it. It should work. But we have to set up all the other stuff as well to get the process ID from the name of the process. So we're just going to do that right now. We need TL help 32. It has the functions that we need to actually do this. Now would be a good time to switch over my project settings, because one of the definitions is screwed up, so it'll give me the wrong one if I don't set it to multi-byte. This is the one we need. One caveat, you have to set the size field before using the structure, otherwise the functions will fail. I don't know why, but I guess they're just lazy, you know. Can't blame them. Also need a handle. Create tool help 32 snapshot, and the process ID is going to be 0. I don't really remember the flags off the top of my head. Just type some stuff in until we get it. Oh, there we go. Nope. So we're going to return 0 on error, just so this one will fail later. But now we loop through the process list. Now, for every process, this will loop through. So in here, we can check for the name by looking through the structures fields. The name is actually SZ.exe file. So we're just going to compare that to the process name, and if it is, then we're going to return the process ID. I'm not going to bother freeing the handle here because it's one function. Demo shit anyway. Okay. So now we should be able to do this. Just for testing. Just make sure that's correct, actually. Yeah. Now, we can just inject the DLL. Now we're going to need the path to the DLL. So we'll make the DLL after this. But make sure this is correct. Yeah. Compile it. Now we can make the DLL. So let's just open up a new instance here real quick. Make the DLL. We're going to want to set the application type to DLL. And load library A calls the DLL's DLL main export. So the definition is as follows. The DLL argument is actually the base address of the DLL, which could be needed for other things. You probably won't use it. The reason is important. It tells you whether or not you've been injected or you're being unloaded, so you don't run your code multiple times. And reserved is reserved. You can't use it. It's used by the loader lock for something, but it's complicated shit that you don't care about. We're always going to return true, and DLL process attaches the one we want because it notifies us that we've just been loaded. Now it's very important that you never do any, memory allocations or stuff like that inside the DLL main. You actually want to create a thread, and even that is really unsafe, but it's better than doing it all in the DLL main. Okay, so this is going to be our worker function, and it's just going to throw a simple message box up, null for the current window. Make sure you make this standard call, otherwise the other application might not run properly. You could get away with that if it's all inside one application, it's all your code, but load library is going to expect a standard call, and it might crash if you don't have that, depending on how much is still on the stack. Okay, I don't need this anymore. So let's grab this, change the name so it fits this. Now when we run this, it should work.